videotape our lectures so that we can, if people are sick or if they're confused when they're doing their homework, they can rewatch it. Yeah. And Moshi, fortunately, is not behind because he watched all the videos, right?
Yeah.
Very cool. I'm very happy. Yes, you may. Go ahead. All right. So, how many people are really comfortable with decimals?
No, I'm
Awesome.
Decimals are awesome.
That's awesome.
kind of like right in the middle.
Decimals are cool.
Guys, this is a video, guys. Guys, this is a video, right? So great. So if you're really comfortable with fractions, that's awesome. If you want to do it that way, that's great. But just as with fractions, you know how with fractions in one move we were able to in one move we were actually able to just get rid of all fractions. We can do the same thing with decimals. In one move we can get rid of all decimals. Yes.
I go to the bathroom, also x equals 2.
Awesome.
Wow.
Can I go to the bathroom?
What? Oh, somebody. Oh, yeah.
Could you just flip it?
Like subtract and do normal things.
0 to 1. And that's a fraction.
What?
That's a fraction.
That is true. That is true. Yeah, like look had a very interesting thought. What is that? 0.4.
Oh, 4/10.
As a fraction.
4/10.
So it's 4/10, right? 4/10 x plus 8/10 is equal to,
And 6/10.
okay,
16/10. Or 16.
or I think it'd be easier to do that, don't you think? And then if we multiply everything by 10, right? Times 10, times 10, times 10, right? And so suddenly all I have is 4x plus 8 is equal to 16. Now that's a lot easier to solve. Don't you agree with me? A lot easier. Now the question I have is, would we have to go to this, would we have to write this into a fraction in order to multiply by 10? Gardner.
No, you wouldn't, because if you multiply by 10, you just move the decimal place 1.
Right, you guys know that, right? If you have 2.43 and you multiply it times 10, there's 1 0, right? You're making it bigger, you move the decimal place 1 place, so it's 24.3. Does that make sense?
Okay.
When you multiply by 10, you move the decimal over the number of places that there is the number of zeros, right? You're multiplying by 10, there's 1 0, you're moving it over 1 place. What if I multiplied 2.43 times 100?
You would move it 2 places.
I would move it. There's 2 zeros, so I move it 2 places, right?
143.
Does that make sense? Right? You all get that? So immediately, by just doing this, I could write this. Does that make sense? Because I just moved the decimal place over 1 to the right, decimal place over 1 to the right, decimal place over 1 to the right. And suddenly I have an easy problem. I subtract 8, and unfortunately, Mushi was correct.
Unfortunately.
Right?
Unfortunately.
Okay, so I'll just move over here. So that was our number, that's our first problem.
Oh, that's pretty easy.
Pretty easy, right?
Pretty
No, it
simple.
isn't.
All right, so let's say I did this.
Just jinx it.
Um,
If you say it's easy, it's going to do everything in its power to make it harder.
No, he's 117. Gary's going to make it everything in his power to make it as easy as possible. In learning wise, he's going to try and make sure that we understand it.
Make sure you understand.
He might make it easier to understand, Gardner.
What was that?
This is interesting.
Fly into the air and I'm like,
all right, what would I do?
see, James, you
By
genius.
1,000.
Okay, Basie, what would I do?
I have the.
No, okay, oh yeah, go.
Ow.
I prefer if you wait till after the lecture though, Basie, if you have to. Okay. Yeah.
You would multiply it by 1,000.
Multiply times 1,000. Why 1,000?
Oh, because there's 3. Because
There's 3 zeros in 1,000, right? And there's 3 spaces that I've got to move it over.
Oh, yeah.
So I'm going to multiply it times 1,000. right? And suddenly that's gonna move boom, 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 so that gives me 2x plus boom, 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 which is 120, equals boom, 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 which is 400. And then I subtract 120, subtract 120, I've got 2x is equal to, what is that, 280?
Yeah.
And then
380. It's 380. 380.
380. 380. No, it's not.
280.
Oh yeah, it is 280, isn't it?
Yeah, this is 280.
That's 280 because you subtract 100 from 400.
Right.
It's 300.
Guys. Divide by 2, x is equal to 140, right? Did I do that one, right?
Yeah.
X equals 140. Does that make sense? All right, so now, if that's the case, if that makes sense to you,
Uh-oh.
James is like,
Uh-oh.
still like, Gary have mercy on us.
all right, let's say we have, this is number 3, right? Guys, a little too noisy. What if we had point 0, 1, x minus 0.2 x, I mean not 2x, 0.2 equals point 2, 2, 0.
All I have to say is you're welcome.
Now, what's the problem with this?
Oh.
What is the problem with this?
I think I know.
Does anybody see the problem? Sienna?
Well, you can't just go with number 2. All the decimals, they have the same number of places.
Right, they all have the same number of places, so multiplying by 1,000 was perfect.
Yeah.
But
Well,
we
this
don't
one-
have this with
yeah,
this one.
this one, they're all
So,
different.
Jaden, what's your idea?
Maybe we can get the 1,000 and move all of them by the 1,000.
Exactly. If you look for the one that has the largest number of places, right? And then you would multiply it times 1,000, basically, since there's 3 digits, you'd multiply it times 1,000, okay? And that will just mean, so I've got to move this over, boom, boom, and then one more, so that's a 10. You see that?
Yes.
Because there's a 0 there. And this has got to be minus, boom, 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 that's 200, is equal to boom, 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 which is 220, right? And now suddenly it's easy, right? It's very easy, right? We have 10x, sorry. We're going to add 200, and then we have 10x is equal to 420. Divide by 10, what do I have?
42.
42.
Okay, wait, sorry,
Wait,
Gary.
Gary.
You wrote 100, but then you multiplied
Yeah.
by 1,000.
Yeah, it's 1,000,
Sorry.
right?
But you could only,
You could
only
multiply
need
by
to.
10.
Technically, I only needed to multiply by 100,
Yeah.
but
No,
I,
you could do it by 10.
No.
why could I do it by 100? Mushi, can you explain that?
Because zero
Because the
doesn't.
zero
Because
at
that
the end
0,
of
I could have erased that 0, right?
Yeah.
And then I would have been able to multiply times 100, right? But, so either way, in that case, and this one would work. Are you guys understanding this method?
Yes.
Yeah.
It's a pretty awesome method because it just immediately, if you do the decimal, if you keep it in a decimal form, the chances of making mistakes are a little higher. Don't you agree with me? Unless you have a calculator or unless you actually do long division. Because, most of us don't really totally, we don't use decimals enough in our brains, like to say, well, let's see, what 1.6 divided by 0.02 is. You know what I mean? I don't know if that's going to be, is that going to be 8 or is that going to be,
It'll be 8.
80 or is that going to be 0.8? You know what I'm saying? You kind of have to figure it out. But once you get it, once you convert it, it's really, really a piece of cake. It's really easy to do. Does that make sense? Question, Jan, or statement or comment? Nothing. Or your hand. I thought your hand was up. Okay. All right, let's try one more. Just be sure that we're. Let me look at. Oh, actually, maybe not one more. Maybe more than one. I don't know. Let me see. What if I gave you? All right. what if I gave you something like this? 0.0,
I'm sorry, what? Can you repeat?
Daniel House. That's trying for Luke.
Oh, no. This is gonna be bad.
I don't know, 0.48. So, as you look at the, what is this, number 4 or 5?
4.
4.
Okay, as you look at this, what would you do?
0.00. I guess.
Jan, what would you do?
I would first multiply by 100. I multiply those. Well, you could just
I would.
5,000. Sorry, yeah, and then you would just get 2x plus 8 equals 48.
Okay, all right, what would you do?
I guess you could do the distributive property first, but I mean
You
that'd be
could do the
really
distributive property first.
Well,
Um,
that'd be
That would be a
That'd
bit.
be too hard.
It'd be easier to do it Jan's way though.
Yeah, I think Jan's way would be easier.
Yeah.
But I would actually say there's actually an easier method. I mean, I agree to the first part of what Jan said. Let's try it.
Okay.
Luke, do you have an idea?
Did you take away 1 0 from each?
I can't do that. The only time I can do that is if it's to the right. You know what I'm saying? Because 0.048 is the same as 0.04800000000. You can put as many zeros as you want to.
No, please, Gary,
Instead of check
no.
mark.
What's the check mark
Um,
for?
Right? So, but it's a good idea. So let's start with Jan's idea. Jan said, let's multiply everything times 1,000.
Okay.
Now the question I have is, do I have to multiply this times 1,000 too?
No.
No.
Just the two numbers. Whenever you do it to one side, you got to do it to the other.
Right, but when I'm doing it to this side, am I multiplying it times this, and times this,
No.
and times this?
Because those are
No.
Now why?
Because it's in parentheses.
Because you can.
because they're not decimals.
Seriously, why?
Because I feel like it.
Because the parentheses.
Guys, listen, this is important. Guys, Logan, this is important.
The parentheses shield them, and so you can't.
In essence, think about it. This is being multiplied. It's busy being multiplying times this and this. Do you agree with me? This number is already busy being multiplying times these two. We haven't finished it yet. But if I multiply by 1,000 on both sides, I can just multiply the 1,000 times this. And then when I multiply it times this, the result of this, it means everything's getting multiplied times 1,000. Does that make sense? So I don't want to multiply the x plus 4. Right away. I'm just going to be multiplying this times 1,000 and this times 1,000. So by doing that, that gives me 2x plus 4 equals 48. Does everybody see that? You see that? Now, what Jan said, and he's totally right, but I'm just going to, sometimes there's an easier method, right? And the other method is, notice, 2 is being multiplied times this, right? What if I just divided both sides by 2? Now, because think about it. This is 2 factors equal 48. Well, if I divide by one of the factors, then that crosses out. Does that make sense? Think about it. Right? Does that make sense?
Yeah.
2 factors. 6 times 3 is equal to 18. If I divide by 6, I get 3 is equal to 3, right? It works, right? So in this case, I'm dividing by 2. I'm not going to divide 2 into this because that's one of the factors. I'm just dividing, you see what I'm saying? So suddenly, I get x plus 4 is equal to 24.
Oh, what?
Subtract 4, right? X is equal to 20.
Oh.
You see that
Yeah.
trick? Now you don't have to do that. You can do the distributive property like Jan said, right? But you have that option. When you have parentheses, when you've got a number times a block in the parentheses, right? And that number in front of the parentheses divides evenly into this number, a lot of times I'll just choose to divide it out right away. Does that make sense? and then suddenly I've got a really easy problem. Really easy.
Oh, okay, yeah,
Does that make sense? So that's just another method. You can use a distributive property, totally fine, but that's just another method, right? And I think that's it. Any questions at all?
Nope.
You guys get it? Awesome, great.